for the future, especially if we're planning to invest, AKA our money here. But let me go ahead and clear or purchase items here. We can go ahead and apply this into the real life. So today we're going to go ahead and model exponential growth and decay. Now, modeling and actually just applying the transformations how we've been used to doing is sort of the same item, but yet differently. We're going to have the same equation that we've had. We're just going to apply new values or new terms to it, just so we can go ahead and apply it to real life situations, okay? So here we go, modeling exponential growth and decay. So here is our definition. We have our functions. We went over this last time, or transformations. Now, this is a different type of exponential model that we're going to go ahead and see today. Now, this time we're going to have our function, and instead of having x in our variable, we're going to have t. Now, t is going to represent time, our variable t, not f of t. And we're going to go ahead and depend or basically manipulate our beautiful function depending on what the time is given. So that's basically our dependent or independent constriction here. It's going to tell us where we're located depending on our time. So our time is going to tell us what our value is here. Okay. So here's our first value that I'm going to go ahead and talk about. So f of t is basically our output, our final result. Okay, so just how we have x and y, when we input x, y is going to be that final result. Our final amount is f of t. A is going to be the initial amount. So we're going to have an initial value. We're going to go ahead and start with so much money or so much quantity of something, so much data, whatever we are looking and analyzing. R is going to be that rate. So it's going to tell us a rate. Something's going to happen to that initial amount. We don't know what it's going to be. It's either going to be positive or it's going to be not in the negative direction, but it's going to be less than 1. And like I said, T is going to represent our beautiful time. So we're going to have these 4 values: our final amount, our initial amount, our rate of increase. It's going to be given as a decimal value that we're going to go ahead and make a note of that. And we're going to have our beautiful time. Now, ready to apply all this? All right. Now, it is an exponential function because we have a beautiful exponent here. Very similar to our basic or our previous model right here. Notice that A is still present, our initial value, and our exponent is still there. This time we don't have an asymptote because we're not going to add or subtract anything to it. We're just going to go ahead and analyze something. Now, something that I want to also focus on, guys, is that whenever we have a growth factor or something that is going to help increase our value here over time, notice that our variable here is time, it's going to be 1 plus whatever rate we have given, okay? So 1 plus the rate that's given is going to be growth factor. Our decay factor is going to be what's missing. So for example, if we have something that depreciates in value, we want to know what is still appreciated of it. So we're going to go ahead and have 1 and we're going to subtract the rate of it. So we're taking the opposite of it. So we have 1 minus that R. So we want to focus on the positive side, not the negative side, away from it. Okay, ready? Ready for our first example? Okay, go ahead and copy this one down, guys. Number 1, it says if you put $500 into a bank account that pays 4.25% interest a year, how much will you have in the account after 5 years? So this is something that you guys can apply in real life, believe it or not. Beautiful. Okay, so I put my equation here, my modeling equation. Now, what do you think is going to happen? Are we going to go ahead and have exponential growth or decay in this case? Growth. How do we know we're going to have interest rate that pays 4.25% per year. So your money is going to grow as you put it in your bank account. Okay, so let's go ahead and identify the parts. How or what is our initial value? What did we put in our bank when we open the account? 500. So our A is going to be $500. So that's our initial value. Why did I write a zero like that? Now, in this case, we're going to go ahead and find our rate. Our rate is 4.25%. Now, the rate here, this is my A. My rate, I have to make it into a decimal value. Since it's a percentage, I have to transform it or change it into a decimal value. So what would it be here? I have to divide it by 100 or move the decimal value twice to my beautiful left. So it would be 0.0425. 0.0425. So I can get it into a decimal value. And what is my time? 5 years, so 5. All right, now I have my A, I have my R, and I have my T. I can go ahead and solve for my beautiful final amount. So let's go ahead and substitute our values. F of T, or F of 5 in this case, because we have 5 years. Equals, my initial amount was 500. My item here, we said it was growth. So it's 1 plus, we're gonna go ahead and grow it. And my rate is at 0.0425 per year. So how many years we said? We said 5. Now in your calculator, you're gonna go ahead and input all this value here. What do you guys get? Let me go ahead and simplify it just a little bit more. Let me go ahead and simplify it just a little more. Bless you, 500. 1 plus 0.0425, so it's 1.0425 to the power of 5 now. So we have our beautiful initial value, our increasing rate, and the number of years that we have here. So it would be approximately, what did you guys get again? 615 and so, my goodness gracious, where's my tool? There you go. $615 and what's my change? More or less 67 and so on and so forth. So my amount that I'll have, my F of 5 in this case, would be at $615 here in this case. If I want to know how much it would increase, you would go ahead and subtract 500, and we know that it would increase by $115 per se. You know, not too bad, huh? No? So one thing that we have to do is identify our initial value, which is our A, our rate, what is it going towards, or what is it growing or decaying in this case, or here was growth, and the amount of time that was given for it to grow or decay. Okay, let me go ahead and save an image. Let me go ahead and, ready? Interest was your percentage.
It's how much money the bank gives you to put your money
in their bank. Yes. So we have to change it from a percentage to a decimal value. So the way that we do that is that we divide, or actually, divide by 100. Since it's a percentage, we need to make it into a decimal value. We divide either by 100 or move our decimal value twice to the left.
No, I was speaking at 9 math.
Like, what's the importance of this?
Okay,
No,
somebody
like,
can charge
so-
you interest?
Do you not get, you don't get charged when your money is in the bank, right? You don't charge.
Depending on the account that you get. There's some banks that, all right, so this time we have movie tickets, and now the average price for that ticket is $9.50, excuse me, a ticket, but increased 15% per year, which seems kind of relative to us. How much are movie tickets now? Like $10? No, there's,
Cinema, like $9, right?
they're $9, right? And then Tuesdays are like $5, no? And then Matinee, I don't know what the price is.
No,
Like.
that's still is five, nothing now.
Most likely still 5. Matinee, like between, you go from like, oh, the first showing to like, before 5. So like during the day, you go in the morning time. Well, it's not morning, but it's like afternoon. You go in the afternoon, not in the evening. Okay, so movie tickets are $9.50 a ticket, increase 15% per year. How much will they cost in 4 years? So let's go ahead and see how much inflation are we gonna have in this movie ticket price. So let's see, we're gonna go ahead and see who can tell me my initial value, who's gonna be my participant today, who's gonna participate. A ver, I got 14, who's 14? Angel, you're my 14 here. All right, so what is my beautiful initial value? What is the initial? 1, 2, 3, 4, 5, 6, 7, 14. Who's 14 then? Oh, Alanis. I was going the other way around. Go ahead, tell me my initial value. What is the price that we start with? $9.50. So my initial value A is going to be $9.50. Okay. Now, what's going to be my rate? Do you want to pass it on? Let's go ahead and randomly select another person. Let's see. Let's see. 20, 15, 16, 17, 18, 19, 20. Zenas. What is my beautiful rate? What is my R? 0.15. So my rate is going to be 0.15. And the last item here, what is my time? How many years are going to pass, or how many months? What is the time that we're looking at? And notice that time has to be in the same base, guys. So if we're talking about years, there has to be years. If we're talking about months, we have to talk about months. We can't talk about years and so many months. It has to be all in one unit. All right, 18, who's my 18, 19, 20, 19, 20, Mario. What is my time? How much time? 4 years. So my time is 4. All right, so it's asking us to analyze that last amount. So our final amount. So how do we write this? It's going to be F of 4. My initial amount, we said it was $9.50. Now my rate, we said we are increasing or decreasing? Increasing, so we're going to have plus, 1 plus. Our rate is 0.15. And the time after 4 years. Okay, so we're gonna go ahead and put it to the power of 4. 0.15 is our percent. We need to create this into a decimal. So yeah, we have to create into a decimal value, which is, yeah, there you go. 1, 2. So that's where we get 0.15. Okay. All right, now let's go ahead and figure out what our F of 4 is. At 4 years, we have 9.50 times 1.15 at 4 years. What do we get here? 16.6. 16.6. Is that what we get? Yeah, 16.6. So our F of 4 after 4 years, it would be at 16.6. Raise your hand if you got that, guys, and you guys have your beautiful calculators, and that is correct. All right, not too bad, huh? What do you mean? Like do one for reals, like something that is for reals for us? Well, we have to find out. It depends on which one you want. No, now the used cars are, they're marked up. They're marked up more. They're marked, yes, used cars are more expensive than brand new cars right now because of the demand. So once you guys, nice. Okay, so this time we have a cost of a brand new car is $25,000. Let's say that it's like a little Corolla or a little, what small cars are there? There's some small. Prius. A Prius, something small. Something super small, and it seems about true. Now, as soon as you guys drive it out of the parking lot at the dealership, it depreciates automatically.
Wait.
Even though you just drove it for like not even a mile, it depreciates. Like depreciates means that it loses value.
Oh,
I think it's like $10,000. As soon as you cross the lot line, it's like $10,000.
It depreciates. I don't know how they calculate their percentages, but as soon as you drive it off and you want to return it the next day, they'll charge you something because obviously they have to restock it, whatever, whatnot, and they'll have to put it as a used vehicle. Now, how much will the car be worth after 12 years? So let's say that it depreciates, meaning that it loses value at a rate out of 7% per year. So let's go ahead and see who wants to tell me my initial value. Who was last? Dinas, go ahead and pass it on. Or was it Mario? Mario, go ahead and pass it on. Gina, what's my initial value? 25,000. So I have A equals 25,000. Now, what is my beautiful rate? Gina, pass it on. No, pass it on. Andrea, what is my beautiful value in decimal value? 0 point close. There you go, 0.7. Remember that we have to move it twice, 1, 2. So it's add that 0 in front of that 7. So my rate is 0.07. All right, and what is the time in this case? Gina, Andrea, pass it on. Jessica, what's my time? 12 years. All right, so this time it's going to depreciate, meaning that it's going to lose value. So are we going to add or subtract? We're going to go ahead and subtract in this case because it depreciates and loses value. Now, we are talking about 12 years. So we want to know after how many years, so we can know our final value. Our initial value, we said it was 25,000. We have 1 minus 0.07 to the power of 12. Now, something that I want you guys to know that whenever we're looking at depreciation or decay or anything that loses value or loses its data or it goes down, we're not going to look at the negative aspect of it. We're going to go ahead and look at what is left of it. So if we have 1 and it loses 7% per year, how much does it have left that every year? 93. So we're going to go ahead and look at 93. So $25,000. We're going to look at 93. So 0.93 at 12 to the 12th power. So let's go ahead and see what we get. What do we got? After how many years? After 12 years, we said? How much is it worth?
Does it go down like 7% a year?
It goes 7% down a year. So after the year is done, 7%, and then after that year is another 7%, and then but compared to the first year, it lost the 14%. It goes down.
So would that would be the same as the map too? Like, would it show like that?
Yeah, it will show the same way. Oh, not like in real life, you mean?
No, like I'm saying like right now, like it would make sense to do it.
It would make, yeah, it should make sense. Okay, so what is your beautiful value here? How much would it cost after 12 years, guys? You guys have calculators? $10,464 and 91 cents. So 12 years, it lost almost a lot of it. Yeah, almost half, well, actually more than half of it. So it lost a lot of value, but again, it drove it for a lot of time. And I don't think that would happen now and day. I think it would be more.
wait, you built up for 12 years?
And it lost more than half of it, but
12 years.
That's not bad, right?
it's not bad, but if you were to go ahead and trade it in, they wouldn't give you that much. It would be worth 10,000. Yeah, they'll give you like half of that.
Oh, no.
whenever you go and trade it in, they'll give you half of that. Because my mom had a car, she drove it, it was a 2009 Scion something. And it was appreciated for like 7 something. And they only wanted to give her $3,000 for it. So my mom sold it outside. So we found a better deal somewhere else. Okay. All right. With that said, any questions on all this? No? Okay, let me go ahead and